The map interface in Java is a part of the java.util package and represents a mapping between a key and a value. The map interface allows developers to store, retrieve, and manipulate data based on the key-value pair. In addition, the map interface also provides various useful methods such as size, isEmpty, contains key, contains value, get, put, remove, etc., which helps in performing operations over the map. Multiple implementations of map interface are present in Java, such as hashmap, treemap, linked hashmap, etc. Let's look at some problems map objects are good at solving. How do we quickly find a person based on ID from a large list of people? This problem can easily be solved using a map data structure. A hash map is a data structure that allows for speedy lookup times and data retrieval. If we load the list of people into a map, for example, a hash map with person ID as key and person object as value, we can easily retrieve the corresponding person object from the hash map by using the person's ID as lookup key. Let's look at the code implementation for this problem. Open map example1 file from Project Explorer in IntelliJ. Let's demonstrate the use of maps in Java in this program. The createPeople map method creates a map object with person UID as the key and person object as the value. The code uses a for loop to generate 1000 person objects, each with a unique UID, first name, last name, email, and nationality. The person objects are then added to the map object with the UID as the key. We'll create a map by invoking the createPeople map method. Let's find the last person added to the map using the UID as the key. In real-world programs, you could imagine an extensive list, and if we want to optimize our code for fast retrieval of objects, we would then use a map. Since we have used a map here, the search is speedy and only takes a constant amount of time. Here we are searching for the last person added to the map. If we were searching within a list, we would have to iterate all elements till the end before finding the person. Since we have created a map, searching by key is only a constant time operation, O of 1, in big O notation. Now let's run the program and see the results. We have the last person from the list printed, and the operation just took a constant amount of time since we used a map. Our program demonstrates maps in Java. We created a map object with person UID as the key and person object as the value. We then used the map to search for the last person added to the map, showing that searching by key is a constant time operation. Maps allow for efficient operations compared to a list requiring iterating all elements before finding the desired one. Our following problem statement is finding all duplicate elements from a list. This problem can also be solved using a map data structure. A hash map can find all duplicate elements from a list by tracking each element added to the map. When an element is added to the map, we increase the occurrence count for the element. Elements which occur more than once are duplicates. Use of hash map for solving this problem allows for faster lookup times and improved performance compared to manually searching through a list. Let's dive into the code implementation for this problem. Open map example2 file from the Project Explorer in IntelliJ. This program demonstrates how to leverage maps in Java to find duplicate elements in a list. We have a createList method which creates a list of strings and adds some unique and duplicate elements. We'll use a map to find the duplicate elements in the list. We already have the implementation to create and print a list of strings. We'll start by creating a hash map object. Our map will store the item as the key and the count of the item as the value. Next, we'll iterate through the list and check if the item is already in the map. If it is present, we increase the count of the item by 1. If it is not present, we add the item to the map with the count as 1. At this point, we have a hash map which contains the counts of every item from the list. To find the duplicate items, we need to find all items with a count greater than 1. We'll iterate through the keys of the map and get the value of the key. Note that we have stored the count of items as the value. We then check if the count of the item is greater than 1. If it is, we add the item to the result list. Finally, we'll print the result list, which contains the duplicate elements in the list. Let's run the program and verify the results. Our program has correctly identified and printed the duplicate items from the list. Note that finding duplicate elements from a list could be solved in multiple ways. Here we have solved it using map to demonstrate how we could also use maps to keep track of object counts. Our program demonstrates maps in Java by using a map to count the occurrence of each element in a given list. We created a map with the elements of the list as keys and the number of times they appear as values. Using the map, our program then checks whether each item appears more than once, resulting in a list with only duplicate elements.